Hello everyone, my name is Kirill Bystrov and I'm warmly welcome you to the first space conference for young generation, for space generation here in Latvia. Personally, I envision future of Latvia in 10 years to be space leading state in certain niche, and I really would like to involve as many people as possible in this particular field. But first of all, I have a question to you. Those who came here, who come here for professional purposes, who come here for to actually to work in space industry or thinking of working in space industry, please raise hand now. Okay, very great. On this conference, you will have a lot of opportunities to find out where to work, how to make applications, and what kind of opportunities there are. And also, who come here just from curiosity, just for fun, about space, space interest. Great. You will have plenty of that as well, because it's both. It's for career focuses and for fun. But first of all, what is Space Generation Advisory Council? Who is? It's one of the organizers of this event, and I would like to first introduce who are they, where they come from, what's their origin. So, Space Generation Advisory Council, it's UN-based, United Nations-based organization. It's a worldwide organization. It was established in Vienna. To support young people, people under 35, in their movement to space, to represent their voice in largest space communities, largest space forums. It's not surprised that on the largest, toppest conference, UN conferences, mostly senior generation are represented, and they are deciding about future of humanity in space. And it was clear for them at one point, it was clear for them that actually their decision is actually more impacting younger generation, because what they decide will come true in 10 years, in 50 years, in 100 years. That's why they decided it's worth that young generation will be present at all UN space-related forums. That's why in 1999 they designed Space Generation Advisory Council to unite people who just interested in space, people who would like to work in space industry in one forum, and from them to collect their ideas, their opinion, and represent their voices on largest space related events, forums in the world. So main Space Generation Advisory Council purpose is, first of all, is to unite young students and young professionals, for those who are interested in space research, and different space applications, like space biology, space chemistry, space law and diplomacy, space project management, and many others, to unite them and to offer different programs, different events, different opportunities for learning and developing. So I would like to show, before we proceed, I would like to show you a small video from Space Generation Advisory Council. It was designed this year for, wait a second, I will make it. Space Generation Advisory Council, join us. It's absolutely free. Membership is absolutely free. And it's starting from this year, we're going to be very active in Latvia. As you understand, it's based in different states. This year, Space Generation in Latvia moved to Latvia. As you see, there are 6 regions, 150 countries, and plus 15,000 members worldwide. So what are the main 5 pillars of Space Generation Advisory Council? It's events like this, space parties, so fun events as well. It's project groups, so if you are interested in particular topic, like a material science topic, you actually can reach out to of your age students from different states who are already working on projects, already making contribution to space industry research. There are groups like, for instance, space business as well, which you can already join and make together startups, make together different businesses already now. Professional development. Through this Generation Council, it's possible to you develop further in space career, receive scholarship, and also to be involved in United Nations related activities. So what you see now, it's main projects, Space Generation Advisory Council projects at the moment. So as you see, there are from all different range of topics, like there is space medicine and life sciences, ethics and human rights, space law and policy, and lots of and many others. Also, if you join, there is opportunity for scholarships. You can there are 140 scholarships distributed each year for members. And as for professional development, there are Space Generation Advisory Council vacancies inside the organization. So you can apply and already receive experience. There are mentorship program. So if you plan a career, space career, and you do not know how to start, where to go, what steps should be, this is a program for you to advance and clear all your questions. Also, there are Space Generation Advisory Council jobs. So if you're looking for space jobs, you can start here and make first applications. And again, there are United Nations related activities. So as I said, Space Generation Advisory Council is represented at largest and important world space forums. And as, for example, United Nations Scopus. And here I would like to show you a video about our executive director at explaining what we do at UN Scopus.
Hi, my name is Clementine de Koopman. I am the executive director of the Space Generation Advisory Council. We are here in Vienna at the Committee on the Peaceful Uses of Outer Space. One of the mandates of HGSC was set 20 years ago, and it is to employ the creativity and vigor of the youth in advancing humanity through the peaceful uses of outer space. So one of the ways we represent your voice at the United Nations is by presenting reports at the Scientific and Technical Subcommittee, the Legal Subcommittee, and the General Assembly of Scopus, and by presenting the outcome of your working group or recommendations or giving an update on our project group activity. We continue our mission to represent the voice of the next generation at the United Nations.
This was Executive Director of Space Generation Advisory Council about our work at UN Scopus. Okay, this is YouTube. Let's proceed to what we're actually going to do here. So first part is our speakers on different topics. It's from 10 to 1 o'clock. We'll have Gertrude Talvik from European Space Agency, and others space leaders in Latvia, who will going to present you topics on, for example, biology, material science, and others. It will be until 1 o'clock. Then it will be lunch and networking. And the second part from 2 to 4 is actually for those who would like to participate in Space Generation Advisory Council organizing committee. So from 2 to 4, if you decided that you actually want to input in Latvia, input in Space Latvia, and also you want to develop yourself on this path, please stay until 2 to 4. We will do brainstorming activities to make Latvia great in space. So before we proceed, important information. If you are interested in space activities in Latvia, please join and follow Facebook page Space Latvia. I'm going to post there all Space Generation Advisory Council events, all any other space events available in Latvia, which I know, and also about life of startups, different startups in Latvia connected to space. Okay, so let's start. Our first speaker is from European Space Agency, is Gertrud Talvik, and she will present a topic on European Space Agency careers opportunity. And please welcome her on stage. Let me find your presentation. So before she starts, I would like to say a few words about Gertrud. She's a representative of European Space Agency. She who can guess from which state she came from? Yeah, she came from neighboring state Estonia, who already part of European Space Agency. They're members. Gertrud is industrial policy officer, who is responsible for implementing of research and development projects in broad range of space technologies for new member states and European cooperating states of European Space Agency. And she is also a technical support to life science and human space life projects. So please welcome Gertrud Talvik.
Hello, good morning. I didn't tell him any of that, so I'm quite surprised that he knew that. Indeed, I'm from Estonia. I work at ESA. And my script for today was to give a motivational speech and tell you about the opportunities to work at ESA. However, this is my third country this week, doing very different things. So I'm super tired, and I also get the morning crowd, but I'll try to do my best. When I joined the space agency, they didn't tell me that they're going to be sending me everywhere else but space. So that's one thing to bear in mind. So firstly, you already got my background, but a little bit in more detail. About 3 years ago, I was in Cape Town, South Africa. I was spending my days and nights in a lab working on eukaryotic transcription mechanisms. So out of the 8.7 million species in the world, I chose one species, and out of its 20,000 genes, I investigated one variant of its one gene and how it anneals to certain DNA regions. So my world had become very, very tiny in that sense, and I was looking to create more space in my life, and I had a passion for space for a while. So I saw an opportunity at ESA, and I grabbed it, and 3 years later, now I'm employed there. This is just a testament to you don't have to be an engineer or an astrophysicist to get an opportunity to work at ESA. There's plenty of opportunities to go around, and I'll tell you a bit more what you can do. Firstly, I'll give you a cheat sheet. These are some of the things that they're going to be asking you if you do ever consider working for ESA. So firstly, the history of ESA. It was formed in 1975 through the merger of European Space Research Organization and European Launcher Development Organization. It had 10 founding members, but by now there's 22 member states. Latvia currently is a cooperating state, but probably next year it will move on to the higher level of being an associate member. And we also have a cooperation agreement with Canada. So that means that people from these 22 member states can work as staff for ESA, and everyone from the cooperating states and from Canada as well can be a young graduate trainee or have any of the trainee opportunities. Becoming an associate member, that also means that you can work as staff for ESA. So for Latvia, that would be as of next year. So what do? We cover all aspects of spaceflight, almost all technologies. And we have by now 50 years of experience. We've designed and launched 80 spacecraft, and I think there's only one failure within the operational time that we've experienced. Plenty failures outside of the operational time, of course. And we have a lot of facilities, what we call establishments, all over Europe. I'm based at ESTEC, which is the Space Technology and Research Center, which is considered the heart of ESA. We have a massive test center there. I'll tell you a little bit more about it later on. We have a tiny office in UK for telecoms. Our HQ is in Paris. Space Astronomy Center is in Madrid. EO Center is in Frascati in Italy. What else? Our operations center is in Darmstadt, Astronaut Center in Cologne, and the Security and Education Office in Belgium-Redoubt. And that means that in all those locations, we have a lot of opportunities for you to actually be placed there, to work there, or do a graduate traineeship there. In terms of stats, we have 2,300 staff, a little bit of a gender disparity there, a lot less females than males, which is expected. A lot of young graduate trainees. That also means that there are about 100 opportunities currently available. I'll talk about it later on as well. And this is roughly our budget, which largely comes from the member states, but a major contributor is also the European Union. There's a clear distinction between European Union and ESA. ESA is not the space agency of European Union. However, there's a high overlap in the member states themselves, just for your awareness. Again, locations, apart from the ISS going around us, we have ground stations all over the world, in Australia, in Chile, in Maspalomas, Gran Canaria, and also offices in Houston, Washington, and Moscow as well. So, now, what can we offer and what can you do at ESA? So, this is I suppose you can say that about a lot of companies. The work's inspiring, stimulating, team-oriented, social and sports clubs, but I doubt you'd be joining ESA for the golf club. You know, I think the main thing would be this. We have astronauts. Sadly, the last round was 10 years ago, but I did meet the head of European Astronaut Center a few weeks ago, Frank de Windy. He spent, I think, around 260 days in space himself. And I asked him point blank, so when is the next astronaut call? It's been a while since we've had European astronauts come in, new ones. And he promised me it'll be next year, latest. So if you want, you can apply for that, but don't, because I don't want competition. And we have, it's kind of funny to be in a work environment where astronauts pass you by in the hallway. And we have a large WhatsApp group with the young people of ESA, and something we call an astronaut alert. So when somebody sees an astronaut, then we pin the location of the astronaut, and then you have about 250 young people starting walking towards the place like zombies. But it's definitely inspiring and interesting. In terms of what you can do, as I mentioned, it's not just astrophysics and engineering. There are a lot of backgrounds that can be applied to very different establishments of ESA. As I said, the technical heart is ESTEC in the Netherlands, but even in Germany, Italy, Spain, UK, there's a lot you can do and apply for. And these are only the technical and scientific stuff. There's also the support functions that apply to every single location of ESA. So in finance, law, in HR, public relations, we have positions for all of those and quite many of those. So it's something that you could also consider. For reference, to work at ESA, you have to have a master's degree. But for any of the trainee opportunities or even fellowships, there are postdoc and research positions as well available. Because I work at ESTEC, a little bit about ESTEC itself. What makes us unique is we have the largest vacuum chamber in Europe, which you can see here. It's called the Large Space Simulator. The idea is to simulate as close as possible the true conditions of space for spacecraft testing. That means that this chamber is about 15 meters tall, 10 meters wide, so it's massive. It's pumped into vacuum over 24 hours. It reaches about the sort of vacuum that's, the pressure is about a billion times lower than at sea level, so currently here. So it's a really powerful vacuum. The whole walls are covered in shrouds and liquid nitrogen is pumped through it to simulate the coldness of space. And what you see back there is actually a mirror array. I think about 20 or 30 xenon lamps are shown right onto the mirrors, which then shine it back onto the spacecraft, simulating the sun. So if you think of the solar constant on Earth is about 1,300 watts per square meter, which is the amount of energy that reaches us from the sun, these xenon lamps are able to produce that in multiple times. So they can actually concentrate that amount of energy onto the spacecraft for those spacecraft that will fly closer to the sun. So a really powerful, really interesting testing facility. So if you work at ESTEC, you can actually go on and see that. What you have here now is the Mercury magnetospheric orbiter, which is one of the 3 parts of Bepi Colombo that launched last year. And for reference, that is about 2 meters in diameter, so quite a big piece. It should give you an idea of how big this vacuum chamber actually is. We also have a massive shock testing table. It works in 6 degrees of freedom. And even spacecraft have been shock tested on it. So a lot of interesting and exciting things happening at ESTEC. There was a time when this machine was turned on, the neighboring villages would start, the lights would start flickering. It's just the energy demand of that is massive. And for large tests spanning over multiple weeks, it's something ridiculous, like we'd consume about half of Netherlands' total energy consumption of the time or something. It's crazy. So once you get in ESA, we actually have a lot of training courses available. So if you get in as a YGT, you can do the technical courses offered to all of our engineers, which is quite a perk and a prerogative. But obviously, you'd have to get in first, and I'll tell you how to do that in a second. So what are we looking for? Again, kind of a classic list: master's or PhD, passions for space, obviously good language skills. More specifically, this is what we can offer. So we have the Young Graduate Trainee Programs, or otherwise known as the YGT program. We have a National Trainees Program for local space agencies, a Research Fellowship Program, Student Placement, and Network Partnering Initiative, or NPI, which is meant for PhDs. Arguably the most popular and the easiest one to get into, well, easiest, is the Young Graduate Trainee. So a recent master's graduate with limited professional experience. So the idea is that you come into ESA for a year and you experience the field of space. And normally you then leave after a year, work in the industry, and hopefully come back to ESA at a later stage. It's advertised mid-November, so the positions opened on the 15th of November. They will close in 2 weeks on the 15th of December. So it's actually the perfect time to be telling you about this. It's on ESA Careers website. I think there's 107 positions available. So there's vacancy notices listed. If you go, what I did is that I went online and I read through every single one of them. Reason being, you can only apply for a single position. So if you find a few that you like, you have to pick and choose. And you have to think also in terms of what's the likelihood of you getting it. Because as you can see, last year there were over 4,500 applications that we received for about 130 positions. So the competition is is pretty strong there as well. Regarding the actual process, it's quite hectic. After the first application, it's an online application. You upload your CV, your motivation letter, you need some references, and you fill in this online form. And then it's silent. Total silence for maybe a month, maybe 2. When I applied, they didn't even tell you that you didn't get it. So still 3 months later, you'd wait and hope. I think now they actually tell you when you didn't get it. If you do get through to the next round is either a Sondre interview or a telephonic interview. Sondre is this terrible online tool where they put a question on the screen, your webcam is running, and a time starts counting down from 3 minutes. And you have exactly 3 minutes to talk to yourself and answer the question on the screen, and then the next question comes on. And that goes on for about 40 minutes, and then it automatically sends it off to the recruiters. It's pretty nerve-wracking. The luckier ones got a phone call, which was, I think, is the better option. And then another 4 weeks go by, and they contact you again if you get through, and that's the final round is an actual face-to-face interview. At my time, wherever you are, they'd fly you into ESTEC or whatever the establishment is, and have a face-to-face interview with you. At that point, you either had 2 or 3 other candidates in the last round, and you actually meet the candidate behind the door, so you know who your competition is. So, and after that, the only thing left is the medical tests. So it's like a mini astronaut application. It feels like it's never gonna work. And in most cases, the YGTs have applied many years in a row. In my case as well, the first year I didn't get it, I heard nothing back. I know of cases where people have applied 7 times, which probably doesn't mean they're young graduate trainees anymore, but still the point is that you shouldn't give up. The competition is hectic, and if you keep to it, I think there's a good chance you'll get through. This I already mentioned. There's a chance to spend your second year of YGT in an industry. So you stay employed by ESA, but ESA places you in big space companies. I didn't do that. I got an extension of my YGT, and then a staff position came up, and I applied for the staff position. And funny enough, the interview process for the staff position was 10 times harder than for the YGT position. So it gets harder as it goes along, but it also gets more rewarding as you go along. National trainee programs, I'm not gonna stop here for long. This is basically a YGT, but it's funded by national space agencies. Since Latvia doesn't have one yet, I'm not gonna talk about it. Research fellowship program. So this is something that when you've attained a recent PhD, you can do postdoc research at ESA. You will get a monetary contribution for that, and I think the positions are online. I think they've posted about twice a year. So if you check the ESA Careers webpage, you'll see those opportunities there as well. Something I forgot to mention, nobody ever talks about money, but for the YGT position, it's not an unpaid internship. Depending on the establishment, your monthly net salary would be somewhere between 2,300, 2,700 euros a month, because we don't pay tax. So it's actually considered a pretty good position even for industry. We have student placements. So it's a 3 to 6 month placement. Normally the positions are open between September and October. So I believe they're already closed, but in some cases they do post additional opportunities. This is normally for either masters or ongoing bachelor students. They have some opportunities to spend a few months at any ESA establishment. And you get a contribution from ESA to cover your basic expenses. I think it's around 600 euros a month or so. ESA Academy, there's a lot of things happening in ESA Academy. However, for a lot of those, you have to be a citizen of a member state or associate state. So this would probably be applicable from next year onwards. Basically, you can You can fly your thesis, you can use our testing facilities to spin your thesis, you can go on parabolic flights if your research work so requires. So there's always obviously a competition for all of those, but you can apply. And what happens afterwards? Normally, the philosophy was that once you come into ESA as a YGT, they spit you out again because you need to gain more experience in industry. Now, there's actually a retirement wave at ESA. In the next 10 years, about 60% of ESA staff will be too old to work there. That means that they have to also change their recruiting policies a little bit, and it's a great opportunity to actually get a job at ESA. So starting from a YGT position now, there are pretty good chances of actually becoming a full staff afterwards. Obviously, more information, everything I just told you in detail would be on the ESA career webpage. Please go and check it out, and do remember that the YGT positions are open until 15th of December. I thought I'd never get it, so I waited until the 15th of December, 2 hours before midnight, and then sat down and thought, I'm gonna regret if I don't try. So in 2 hours, I hacked together this application, sure that I wouldn't get anywhere with it. And every other stage, I was sure I'll never get a phone call back, but I did. So I do recommend you try it as well. And you can always become a bus driver as well. That's also fine. I think I'm over time anyway, but I'll be around. And also I think there's now some time for questions as well. It's super difficult. So if I tell you, how you
dream, like what's your big dream?
Astronaut, of course. Astronaut, yeah.
Okay.
That's the obvious one. But progressing within ESA is really difficult. If you think the DG is what we call A7, I'm A1. And every grade has 12 increments. So between me and DG, there's almost 80 years. So it's, it's a job.
80 years, you need some work to do in biology first and instead civil life.
What is ESA's relationship with recruiting companies? Because I've only had contact with working at ESA through a recruiter that contacted me, and it was a very awkward, weird, and each time there was a chaotic thing involved with that company.
Yeah. So the weird thing, because we're governed by 22 member states, we have a strict cap on how many can be ESA staff because of the benefits that are for ESA staff. So the cap is 2,352, I think. So, but we have multiple recruiting companies around, and for those recruiting contractor positions, there is no cap. So ESA has a lot of positions cap-free, and then these contracting companies are positioning themselves around ESA and then advertising those positions. However, we don't control the conditions they advertise for you, because this falls out of, they're not contracted, you won't be working for ESA. So we have no say in what you will actually, the salary you'll be actually getting and your pension conditions and so on. So, but the good thing about it is that there is also no quota for the contractor positions. So in ESA, because the member states contribute, all member states have a quota for the amount of their nationals that can work at ESA. So for Estonia, it's 2. So I'm 50% of the Estonians at ESA. But for something like Germany and France and so on, it's hundreds. So ESA needs to work within the limits of how many of those nationals they can actually hire as well. Whereas with contracting companies, there is no cap and you don't have to be European. So that's the sort of plus. And it is still worth looking at those positions. They're still really good, and it gives you a way in, because obviously after a few years being a contractor, you have the opportunity to apply for something that would be full staff.
What is the age limit? I mean, what I'm asking is that you said that you might, it might take a long time before you getting an astronaut, but it might never happen. So how do you deal with that? Because in the meantime, you have to do something else, right?
Yeah, so for astronauts specifically, age limit is 27 to 37. Obviously the difficult part is if they have an astronaut call every decade once, you might just fall out of that range.
Then you have to
27
call
to
them.
37?
Mhm.
Luca, the Italian one, is much older than 37.
Yeah, but he was in the call in 2008. So I believe he was something 35 when he was recruited. They're 10 years in training
Okay.
before they even get to fly.
Wow.
Yeah.
All right, let's give a round of applause for Pietro. Thank you very much for this inspiring and very informative talk. The next presenter is she is based in Latvia. She works for planetary science. She has more than 40 years experience. Yes, it's Dr. Amara Grabs. And she, in 2018, she received a European Planet Prize for public engagement with planetary science for her far-reaching work to inspire and promote space activities in the Baltic region within the scientific and industrial communities, in education and in a wider society. So let's give loud applause for Amara Grabs. Yeah, and your here you go. Mhm.
So I'm starting with this picture from my daughter's picture book. And I didn't realize at the time when I had this, it's one of these cardboard books, that all, I don't know, 3-month-olds or something. And this is showing an asteroid miner. And in 2009, when my daughter was born, I had no idea that I would have anything to do with space mining. So I cannot find this book now. I had to take from a scan that I scanned years ago. Somewhere, maybe I gave it up, and I think this was a future glimpse in my life. So I want to start with the story that I spent perhaps a couple of weeks writing to tell the Friends of Europe in, it's a think tank in March. And they wanted me to talk about space exploration and introduce the rest of their speakers, but under 3 minutes, and make it provocative so that everyone had their jaw dropped. And so I really had to think hard on my 3 minutes. And this is my story, and it'll set up what I'm going to present in the rest of this talk. So it is the year 2027. You are the human on Earth operator of a 12U CubeSat currently parked at a fueling station in high Earth orbit, waiting for the arrival of water extracted from a lunar ice patch to fuel your spacecraft's steam engine. You've seen at the Minor Planet Center that a near-Earth asteroid will pass by the Earth at about 3/4 of a lunar distance in 5 days' time. The asteroid is less than 10 meters in diameter with a speed of a few kilometers per second. To have so much lead time on a low-velocity small object is unusual. So you've registered your interest in this object at the International Space Objects Mining Registry. With the tiny object fitting the category of dirt, your fishing license for that volume of space doesn't need to follow a priority rights declaration procedure. Moreover, you are prepared to mine all of that. Such a plan is optimal for safety measures and is the backbone of your business of recycling dead satellites in graveyard orbit. Your business has a partnership with the fueling station company to provide the other company feedstock metals. With such feedstock, the 3D metal printer at the station can construct new metal pieces for itself or other near space operators. Plus, whatever water can be extracted from the small rock will help you refuel your own CubeSat and the water supplies of the fueling station. So the scenario I've just described exhibits technology that exists today, using a regulatory language that is in vigorous discussion at the Hague International Space Resources Governance Working Group since 2016. You young space generation enthusiasts, maybe not so young, but hopefully young too, are in an excellent position at this time to provide the courage and vision to implement the next step of humans as spacefaring beings, which inevitably will use what exists in space to build in space. Space resources can provide an extension of our spaceship Earth to include our robots that are orbiting the Earth and traveling beyond. So with space resources, we can surface, recycle, or build anew in space without the limitations of carrying the resources from the Earth. Telecommunications, Earth observations, planetary research, extraterrestrial life explorations are just a few examples which can be implemented cheaper and more efficiently in space. So, with your courage, you can engage our human resources wherever you are to implement such a vision to bridge the gap from today to 2027. The publicly funded researchers and the private companies building in space need each other. Their goals are complementary. The future we are building needs all hands working, the scientists, the engineers, the lawyers, the venture capitalists, the policymakers, the educators, the students, the business managers, and especially the women and minorities working in all of these fields, because studies have shown that companies and entities with such people at the top are more successful. So I believe that civilization stands at a very special time in space exploration. It's become democratized, so let's go together to our rich future. That's what I want to begin. Your in-space resource utilization future, which is nearly here. So I want to start with some milestones because I was asked to present some current trends in in-space resource utilization. So the first milestone, which really took a couple of years to make into a public policy paper, came from the Luxembourg Ministry of the Economy, which is now the Luxembourg Space Agency. And at the same time, ESA started developing their own when it was clear that that the management company, PricewaterhouseCoopers, needed a little more experience to ask the right questions of the engineers in the space resource companies. So the milestone one is that there is now a roadmap that says what industries need to exist in order to implement mining in space. What are the different technologies? What are the first priorities? So I want to start out with saying the first priority is water. Why water? Well, water is a radiation shield. It can be turned into a steam engine to propel your spacecraft to the next target. It can manage the human operators that are on a body like the moon. I can't imagine human operators doing very much with asteroids. It's a bit tricky there. So water is one of the very first resources that the space miners are interested in. So now we have the Luxembourg Space Agency roadmap. They call it a value chain. And now we have, since this year, we have ESA Space Resource Utilization Strategy 2030, where the goal is to have a human on the moon sustained fully by the year 2030 with the resources that's on the moon. That's the goal. So this explains a little more about the value chain. Water, as I said, is the main object of interest, and raw materials like platinum, metals, gained a lot of publicity 10 years ago, but it was a little bit misleading. People thought, oh, we're going to mine for gold and bring them back to Earth, and everyone will be rich. And actually, that really distracted the whole community for a long time. What we really want is people to extract in space and stay in space and build in space, and water is really a good first priority for that. Okay, so guess what? There are water thrusters flying in space now. They were launched by the company that acquired Deep Space Industries, which is called Bradford Space Industries. And they have now the whole queue of customers from Deep Space Industries, and they're servicing those customers and building more water thrusters. So if you want to have a way to propel your spacecraft with space resources, buy a water thruster. Now, there was a bit of evolution with asteroid mining companies in 2018. The main two companies that gained all of the publicity was Planetary Resources and Deep Space Industries. They each demonstrated a different business model. Planetary Resources was a bit flashy, very management heavy, and they struggled with providing something that could bring in money to the company while they're playing the long game. So the long game is that you want to develop something that will go out to an asteroid, or closer perhaps the moon, that you need to keep your company running while you're building the things for the long game, and it's a very hard gap to fill. So Planetary Resources depended deeply on investors, and there was a moment in the winter of 2018 when one investment that they needed to keep their company afloat didn't come through. And everyone went away. They laid off the company, and they had no assets at the end. And the CEO became acquired by Consensus, a blockchain company. So why a blockchain company? Well, when you think about resources, you want to identify resources with a strong path of ownership, so you understand well where that resource came from, and it's verifiable and legal. And so blockchain is actually quite a good acquisition for Planetary Resources. Now, Deep Space Industries had a different issue, which is that they were already producing water thrusters, but they couldn't scale up fast enough, and there was a queue of customers. And because they couldn't scale up fast enough, their growth had some challenges. And at the end, the CEO presented the company to Bradford Space to just buy them. And Bradford Space is not exactly an asteroid mining company, but they're thinking about it. I understand they're looking hard at this. So those are the lessons learned. Now with those two heavyweights gone, there's fewer companies, now 3 from 5. With 800 asteroid scientists in the world and maybe 3 companies, I understand there are a few smaller ones jumping in and filling very specific niches. So there will be more than 3 by next year. I'm certain about that. I can't tell you what they're doing yet because I'm still learning myself. So this is the second time we held this conference, which is the Asteroid Science Intersections with Mine Engineering. And as I said, there's 800 scientists and just a few companies. The challenge of the companies is it's very expensive to do cutting-edge science. So what if you could engage the scientists to answer your questions? So the format of this workshop was to prepare a list of questions that the companies had, present that to the scientists, and then the scientists would answer those questions. And so this is the second time we had this. This was in Luxembourg also, supported by Luxembourg. This is my ASME idea. And so the first meeting in 2016, it made a roadmap of the science that's needed in order to help the companies go out to the asteroid. So this is an asteroid mining idea. And then 2018 was taking a specific topic of what is asteroid made out of? Because if water is what we want, we need to find out what asteroids are water rich. And that's actually a very small subset of asteroids. So you see the 5 guys representing the companies down here. Okay, 2 of them don't exist. Okay, not that they're dead, actually. You know, one is in Consensus now. He's the one sitting down. And then the one standing behind who works for Rocket Lab. So he's the chief engineer, he works for Rocket Lab, and he gave me some ideas to present to you guys that I'm going to get to in just a couple of minutes. Okay, well, since asteroid mining kind of went through a slump, what happened with the lunar miners? Well, the lunar mining community is much more mature, and it's been growing all along while the asteroid miners are struggling to find that gap problem to be filled. And so the ease about lunar mining is that you don't have to look for the moon, right? The asteroids, you kind of have to spend a lot of money and time to find them and then figure out what to do with that. But the moon is always there. But the moon is also a shared resource, a very precious shared resource, which is why you need the legal community to tell you what you can and can't do. So while the lunar miners are discussing the technology needed to dig and what's there. The first question, how much water is at the poles on the moon? You know, that's rather important if they're going to sustain a human on the moon. So that's, if you look at the ESA space strategy document, that's their first resource of interest. Okay, so don't mind asteroid in space resource utilization, because guess what? You can find asteroid resources on the moon. When I read this from a presentation, I was giddy all over because, you know, I'm an asteroid scientist at heart. And so what if you can support the lunar miners while they're building and doing everything there, and there's much more support there, and there's companies, and it's growing so fast. What if you can get your little asteroid science in, you know, with this way? Okay. So as I said, the legal frameworks are moving. If you go to the Hague International Space Resources Governance Working Group website, you can pick up their document that was just finalized in October. It's 7 pages, it's very concise, and this is their guidelines for the world of making sure that you don't have renegade people cutting into your process happening on an asteroid and taking your hard-earned effort. So it's very clear. It took 3 years to get to this point, and I would say it's the most far-out document I have on my hard disk. Because all of these discussions were exactly, well, what do you do when the rock is only 5 meters? You know, can it be like, you know, a molecule of water in the ocean? You just, you know, drop your fishing line and you maybe get some bacteria, or, you know, how small is small? And if you don't use it all up, well, then that's a problem because there's a hazard for an accident that could endanger other operations nearby. So all of these issues were discussed in great detail, and it's a fantastic document, so I highly recommend looking at that. And meanwhile, there's the UN member states were discussing the revisions of the Outer Space Treaty, and that's ongoing too. It was very, very active in 2018. And I haven't seen an official document. I should browse the UN site a little bit more. Okay, so now there's courses. So the Colorado School of Mines in Colorado has in-space resource utilization courses. They're working closely in Luxembourg. And the University of Luxembourg now has a master's, a space master's that they're modeling after the International Space University. And I just learned last night, preparing for this talk, that the NASA Virtual Institute survey has an online course that they're planning for winter 2020. So when they say winter 2020, is that like next month, or is that a year from now? I suspect it's a year from now, but I'm going to talk with Dan Britt and ask him because I want to follow along too. Because look at all these great topics that's there, right? Mineral evolution, lunar geology, lunar polar water deposits, operating on the moon, thermal processing. This is exactly what you need if you want to learn the topics of space mining and space resource utilization. Okay, so how can you start? Well, this is how I started. I volunteered time at an observatory. In my case, Palomar Observatory. I was helping an astronomer look for asteroids way back in 1982. Okay, that's how long I've been doing this. And work with real data. And that's the important thing, is that it's a really tough field, astronomy is. And if you're not inspired often and early in seeing the result of real data, you're not going to stay in the field. It's just too many filters along the way that are going to challenge you in your life with the moving around often and the three-body family problem. How do you start your family, and your husband's in this country, and your job's here? It's not an easy field to get into at all. So getting in and getting inspired by space early is in my case, I think is very important. So here's some Baltic space facilities, just some blurry pictures. There's the names of those that are fully involved in space. And then there's departments, like inside of RTU, for example, that are doing different space activities. And I include southern Finland because there's a very close relationship between Tartu and Helsinki. They're back and forth constantly. Okay, get involved with the maker community, learn Raspberry Pis and Arduinos. If you don't know what they are, they're little computers that fit in your hand, and you can attach sensors to them and make robots, or you can measure your environment. You can program. The Arduino is now a little more flexible with programming languages. I like Raspberry because of Python. I can program in Python, and Python's like the language for everybody. Okay, and that little Raspberry, the two pictures went to a volcano. I made that. The first picture is in my backyard in Riga, and then those two pictures are at a volcano in Ethiopia. Okay, get involved with a club. So you're doing something and building something, rocketry. So my friend at Rocket Lab, he did that. He also suggested the Formula SAE. These are clubs that build engines for cars, and they're competitions. And I didn't know this at all. So I want to know if there's one in the Baltics. I think that would be an excellent start a new club. And then the Lego First Robotics competitions. There's one in Jelgava that I watched once. And so I know they're growing, these Lego First competitions for robotics. And then just do it. and make a lot of mistakes. We want you to make mistakes because that's how you learn. Okay, there's a couple of key books by John Lewis, Asteroid Mining 101 and Mining the Sky. And read all the science fiction you can, because it'll inspire you as well. I think most people involved in space start with reading science fiction. And here is my first ASME paper that is like a more general roadmap where there's 80 questions from the companies and the scientists answered. So it is technical, but it's organized in a way that you see the questions that the companies are thinking about for mining in space, and you see the answers from the scientists, and then there's references, and so you can go and follow up on any of those references yourself. So I have a database. I have a University of Latvia student helping me on that. I need help. So if you're interested in asteroid surfaces and what those regolith properties are, come talk to me. And then don't forget your school. I'm sorry to say that. I know you want to go out and do space things rather than studying your physics exam, but it's really important that you get the basics. So don't forget your basics. Now, if you are an artist, though, or you're in another field, not exactly a STEM field, there's still a lot of opportunities for you. And that's why this idea STEAM, where A is for art. So artists now are really valuable to the scientists to illustrate and show in some graphical form a very complex science topic. Scientists definitely need that. Okay, so there's I call it my calling card. And let me help you, and I'll answer any of your questions. Thank you.
Questions, feel free to ask now, or otherwise just like in a break to come in one by one.
Mm-hmm.
Okay.
Oh no questions. Okay.
I think it's personal, maybe.
Okay.
Okay.
All right.
Thank you very much for your very interesting talk. I learned a lot myself about asteroid mining. I didn't know about the split between lunar and asteroid. Thank you very much. Next speaker is from RTU. Is Thales Juchnam. He is a professor of water technology and vice rector of for research at Riga Technical University, and he is among top 10 researchers in Latvia. So let's round of applause for Thales Juchnam.
If you say so. Okay.
So
Right. Thank you.
here you go.
Thank you. Good morning. How many RTU students are here? Good. That's why I'm here. Mostly for you guys, but of course. What I'm going to talk about is actually how we are trying to get into the space research, because as it was presented, my background is not a space research. My background is not even in biology. I'm an engineer, but my focus is on water, and over the period of about 15 years since I established my water and biotechnology lab, I realized that many things which are important here in Earth regarding water are very similar. I mean, the problems are very similar as you would have in a space. Just to give you an example, you know the conventional wastewater treatment plant is using bacteria to convert waste like carbon into CO2. So what happens is you generate a lot of CO2 in a conventional wastewater treatment plant. And CO2, as you know, this is the greenhouse gas. And nowadays, we are more and more looking into the technologies which allow to avoid these kind of problems on Earth. And, for example, capturing CO2. And this is what actually the scientists which are designing the spaceship, and they're designing about the system, how to survive in a spaceship. They are actually addressing the same kind of issues. So my background, as I said, is biotechnology, but our university, and there will be another presentation from Kasper Kalniņš, they are very strong in material science. So we are trying to work with space issues more and more. And my field is more related to bacteria and algae. So, but before I start what I'm going to tell about, I'll just give you a little bit of insight. What are the challenges in the space when you talk about using resources? So the first thing is, to make very clear, if you want to survive in a space, you have to find ways to recycle waste, okay? And of course it's being done now. I mean, there are technologies today, like you separate water, urine from water, and then you can drink it again. But all of these technologies are mechanical or chemical. So there's no, at the moment, they are not being any technology which is using biological approach being actually tested in a full scale in a space. And of course, why biology? And the answer is very simple, because biology allows you, in principle, to close the loop. I mean, we are here on the Earth, so it allows to close the loop. And unlike chemical methods or the physical methods, it consumes less energy because basically it can generate energy if you run in a proper way. So that's why one of the challenges is actually how to make biology work for the space application, both when you talk about the spaceship and also maybe in future when we go to the Mars, how to close the loop. The problem with biology is that, it's very unstable. Who actually have some biological background here? You have, of course, you are molecular biologists, but is there anyone from? Okay, but the thing is that this is a very unstable system. I've been studying behavior of bacteria in oligotrophic environments. So it's these environments with very low nutrient content. And we realize this is very difficult to model them. And this is something we need in space, because you need, the second very important thing is not just the safety, but how to provide sustainability of the system, so the system is running for a longer time. And as I learned when we started to work with MELISA project, we are not a part yet of this project. But we have already first cooperation with them. They said, if you want to introduce biology into space, then you need a lot of engineering, because these processes, biological processes, will be controlled by sensors and by very rigid methods of really monitoring what is happening in between different species. So that's why the safety process is very important. And then if you talk about biology, it allows you to reduce the energy consumption, and it also allows you to reduce the weight of the treatment plant, what you are bringing to the space. And 1 kilo costs something like, what is it, 1 kilo, to 20,000 euros, I think. It was 1 kilo to bring it to the space. So if you take the chemical, let's say, membrane filtration unit, it will be much, much heavier comparing to biological unit. Okay. Now, so this is the most famous project, MELISA project. It's running for more than 40 years, and as I said, they still didn't manage to have the first trial really in a space. Again, giving all the challenges I mentioned. But what they have come up is with this nice loop. And as you see, this loop is basically showing the overall principle, how to close the loop, meaning that how to come from the waste back to the products and back to the oxygen, what you need for astronauts. I'm not going into the details too much. I will just say that our focus is this part, which is, do we have a pointer? No, we don't have a pointer. The part about algae. So what we are trying to study is behavior of algae and how to make them more efficient in producing oxygen. I'm coming back to this in a minute, but just a few remarks about this loop. So the idea is that you have the guys, their crew, so they're producing waste. They could be organic waste, but you have urine, you have feces, and then what you're going to do with that? The first stage is anaerobic treatment. In anaerobic treatment, basically what you do, you kind of hydrolyze this waste into CO2. It's not just CO2, but it's mostly CO2, and into the minerals like ammonium. Ammonium is very smelly stuff, what you normally feel when you go to the toilet, and then you have to do something with that. So the next stage would be using other bacteria, converting this into CO2. And then you have a CO2 and oxidized ammonium as a nitrogen, which can then be taken either by microalgae or by the plants. So there are two ways. And you see what happens is if you design in a proper way, you kind of close the loop, because what happens is that you take out carbon, convert it into CO2, you get minerals, and minerals together with carbon are used by algae, and algae produce oxygen. That's what you need. So seems very simple, but that's not that simple, because as I said, the system is very sensitive. And there's a lot of research done. There is the research center which is more than 40 countries and 50 organizations working on different parts of this loop. So as I said, our focus is algae. Why algae? Again, the newest technologies what we are using in Earth application are looking towards this organism. Bacteria is good, but algae is better. Again, for a very simple reason, because they are using CO2. Okay? Our specific focus is how to abstract nutrients from the waste using algae, and particularly phosphorus. This problem hasn't been addressed yet by MELISA project. That's why they are interested to cooperate with us. And the idea is this, that algae, obviously, using phosphorus to generate DNS, and they generate different compounds what they have inside the cell. Then also they convert nitrogen, ammonium into nitrogen. And then, of course, they accumulate these substances, and then they generate oxygen. So, what are the advantages of using algae? It doesn't matter in space or in the Earth application. The first, as I said, there's no need for carbon source. Secondly, if you use aeration, which is a classical method for carbon removal in wastewater treatment plant, you could consume a lot of energy, and the energy quite often is not renewable. In this case, you don't need really aeration because the CO2 is available. Secondly is that bacteria, as I said, they are very good in abstracting nutrients, but when you come to very low concentration of phosphorus, they are not able to reduce phosphorus below 0.1 microgram. And it's very high concentration because it can generate regrowth, it can generate biofilm formation in the system. So bacteria is not very good at this. So algae can do this. And finally, which is also very important, using algae you can generate very many useful products. Like, for example, you can generate lipids, you can get different food supplements, for example, omega-3 oils. Then you also can generate several pharmaceutical compounds, antioxidants, and then chemicals with antiviral properties and so on. You can use it in cosmetics, and very important, you also, as I said, you can abstract phosphorus, and then you can use it for agriculture. So it's a very nice type of organism you can use. So what is our specific thing we are looking at? In wastewater treatment plants, something like 15 years ago, they started to look more closely at the process which is called luxury phosphorus uptake. I'm not going into the details, but the idea is that by stimulating bacteria, you somehow manage to push them to take more phosphorus than they would take up in a normal way. And we started to think about, what about algae? And we managed to find there's some literature about this. Indeed, at the certain conditions, algae are able to take more phosphorus than they would normally take in an environment. So, how to do this? So the approach what we are testing is algae starving. It's like, if you've been put in a cell for several days, you get hungry, and then you get out, your appetite is up, and you eat a lot. So it's something like that. It's not that simple, but you can control looking at different enzymes. And what we observed is that depending on the starvation conditions, you can, let algae either uptake more phosphorus or generate more of the lipids. So in this way, by operating, this reactor, what we are using, by changing the residence time in reactor and different other parameters, you can force algae to take more phosphorus. Why is it important? Okay, before that, the first is that if algae are growing faster and they are taking more of nutrients, you reduce the size. You need something, just rough estimation, you would need 1 cubic meter of algae to abstract CO2 by 1 person generated per day. So it's a huge amount, right? So what we want to do is reduce it 5 times. And as I said, by pushing this luxury uptake, we can hopefully make this happen. And we have some experiments proving this is possible. So we are now testing this in a pilot scale, and and hopefully that would be also very useful for land application, because we have the same problem on submarines, in ships. Water is everywhere, but it's very expensive because then if you recycle, it's much cheaper than take it from the sea and use reverse osmosis and remove salts. So this application could be also used not only in the space. At our university, actually, we are, as engineering university, we are not just doing research, but we also building things. You know, that's what we like to do. Actually, we have one program, and we have a representative of one, actually, this of the course, which is called Vertically Integrated Projects. So the idea there is that what we're trying to do is to bring both high school students, students from university, different academic levels, putting them together so they are working on the real prototypes. So they are studying, you know, how things are working and building also the prototypes. So what we are building now is so-called echo machine. So this is kind of machine what you would put in on the space, but this echo machine would be future also of wastewater treatment here on Earth. So that is my story. Thank you. Questions?
How algae behave in space?
Well, of course, you shouldn't expose them to radiation. You have to be. They are still a bit sensitive organisms, but I think that according to Melissa project, they have one specific, topic looking at the algae behavior on the space. I mean, in a microgravity conditions, and then didn't observe big differences. So basically, you can replicate, the same process here on Earth. So the microgravity didn't affect too much, if this is a question what you ask. Yep.
In your opinion, what is the greatest discovery in biology in space in the last 10 years?
I think in space, I think not in space, but I think it will affect space because we talk about engineering and about molecular engineering, and of course discovery of CRISP is the greatest discovery, not just for the space, but certainly it might be used also for genetic engineering to modify bacteria to, like for example, not only bacteria, humans after some time, but with this technology you can let bacteria to, let's say, or for example algae, to work faster, to do things what we want them to do. So I think this is the greatest discovery. If you know the CRISP, what is CRISP? It's the technology you modify DNA of the cell. Yeah.
Have you ever thought about using these microorganisms in relationship with the mines that are going from space? Not exactly to close the loop, but to open up another loop to try and feed these microorganisms the resources for space, just so you can maybe get another source of some nutrients. Have you ever thought about that?
Well, yeah, of course. You mean if you need to add some more nutrients from outside, or?
Yeah, because there is a broad pool of resources from space.
Yeah.
These mines going from space.
Yeah.
And if you got your microorganisms from here, have you ever thought about using those as storage to get nutrients from the space themselves?
Yeah. Well, this is an interesting topic, but I think we're still too far from that. So I think at this moment what Melissa is looking is really to understand different components of this loop and try to kind of get better mathematical description of what's happening. And then of course you can always think about bringing other organisms into the game, but this loop what they are proposing is kind of I think the gold standard, what they call it. This is the system which most probably will work, because there could be other ways of closing the loop, but this seems to be a most viable approach. I don't know which. Yeah, you.
I think connecting Amara and you, maybe you can both answer about biomining. Is that something that you see happening?
Okay, biomining perhaps is going to converting the minerals into in useful stuff.
I don't nodule of bacteria, right? Or didn't it? Or spores, something, oh, it's a Chinese, I'm sorry. So I'm mixing up recent accidents. Yeah, and so now we have by accident, we've contaminated what is supposed to be a pristine environment because there was not.
There's no. That's a good.
So
Yeah.
my question was actually, does planetary protection make sense anymore if it is so simple and easy to have a bacteria hit your eye in some way and then there's an accident and I don't think this is something you can control anymore.
Yeah. And there's another issue, actually, this is one of our specific topics. Bacteria can enter so-called viable but not culturable state, meaning that you think that they are not there using culture methods, but actually they are not really a spore. I mean, it could be a spore as well, but they could be as not a spore. They can just stay there for years, and then in certain conditions they can thrive. So they are staying in this non-culturable state for ages, not ages, maybe years. So, and that's very difficult. It's risky because basically you have to be very careful if you go to the space and you want, protect this from contamination. I think you have to take into account what technologies actually you are using to detect them. I think molecular biology perhaps helps, but still there's a question about viability. Are they alive? Are they dead? But regarding the mining, I think this is one of the future solutions again, because bacteria work 24/7, so you don't really need energy, additional energy for them to do this. So, and I think that with genetic, especially modification approach, you can let them produce more enzymes. Like we have one project where we're using fungi, because fungi, they produce a lot of enzymes. So, and the enzymes, they can break everything almost, So I think this approach is very viable, but the problem is about, how to control it really, how to kind of make this surrounding safe so you can, this bacteria is eating the right rock, so to say.
Tardigrades is what was in that container that crashed on the moon.
Yeah.
So, and I don't know how long tardigrades can exist in a vacuum in that temperature.
Yeah. Okay.
I was thinking about Lisa's research of trying to mine asteroids. So my question is, the way you mine from these asteroids, is it by chemical, physical processes and then biological processes, or trying to open up another field is biological?
Anything that will work. I mean, I think mechanical, first of all. And one mistake I see, people, I think, are trying to apply terrestrial mining techniques to microgravity. And I think you have to be really careful. And at least the asteroid mining companies, when they were still running, they said that this approach absolutely won't work. You have to take a very different approach and just try a bunch of things, and there will be lots of failures, but it's clear that the same technology doesn't work in microgravity, and you have to develop processes that do. So granular physics is one that is being studied more regularly, and in the ESA space strategy document, not much is mentioned of dust charging, which will get in everything. This electrostatic dust will stick on the suits and on the lenses of your instruments, and so I think there need to be more young, fresh eyes to think about all of these new things that is necessary in space. So don't get caught in a box where everything has to look like mining on Earth, because it doesn't.
Okay, thank you.
Okay, so far we have one speaker about European Space Agency, two speakers about from science background. And now we're going to have a business part, business space and business part. And next speaker is one of the youngest startuppers connected to space in Latvia. He is a winner of Satellite 2019 pitch competition in Washington, USA. And it's Pavel Razmayev. Please give him a round of applause. Also, he's connected to commercialization reactor, and he's going to provide some information about those two topics. If you have questions about how to establish
Just a second.
Yeah, technical. Okay, we have a technical question. Issue is going to be currently resolved. Also, when I was sitting, I decided that actually it would be very worth to say about International Space University. We actually haven't planned to do that, but I believe it would be worth sharing this. In the world, there are a couple of universities which can provide a specialized space education. Just like six years ago, there was only 3 universities in the world that were doing that, and one of that is International Space University. They accept applications from Latvia, and also, moreover, International Space. They provide scholarships for Latvian citizens as well. I've studied there 6 years ago, and the European Space Agency generously supported my application to study there. There are 2 programs which you can participate. So let me show you the site. So this is ISU. It's also called ISU Mafia because it's one of the largest space communities. Correct me if I'm wrong. For instance, there was International Astronomical Congress, one of the largest space events, and 20% of the participants were ISU graduate. This is university have 2 programs. It has Space Studies, more programs, but 2 core programs, Space Studies program and the Master of Space Studies. So Space Studies program is for those who already decided in which space company you would like to work, or what kind of specific career path you want to have. And you come there, you're working like you're a doctor, or you're an engineer, or you're a businessman, or a diplomat, or lawyer. So you come there during the summer period for 9 weeks and being exposure to international space industry experience. You've been taught different space topics, how space industry works, like what is space biology, what is space engineering. So you come from different backgrounds and you've been taught the same subjects to have an overview of what's happening in space industry. Also, the second thing, you have a specialization. For instance, my specialization was space law, space economics, and space diplomacy. It's like a separate department there. So it's a second activity, and third activity it's a space project, which is an awesome. So 100 people from 20 plus states. Been divided into 3 teams, and we've been put like in one box in one room and said, in 9 weeks you need to prepare a space project. Time is you have you have a certain time frame. You have advisors, and you have also we had also special consultants. So this is a huge experience for those who would like to work in space, because it's really difficult to to actually negotiate between different people from different cultural, professional backgrounds. It was a huge challenge. So first period of our project experience was just like to find how to communicate with each other. And this is essential if you would like to work in space industry. This is essential experience, because all projects in space are international. You have to understand how Japanese work, what's their understanding of like meeting culture, how Danish people understand what does it mean meeting. And the next program is a master program. Master program is a one-year program, and it's last 9 months, and 3 months is a research project internship in some particular field. So if you do not know in which space company you would like to work, or you don't have already a specific path, I would advise to try master, space master, because it's a golden ticket to space industry. ICU is well known around the globe, and you first of all you get 9 months of education and experience, and then with the help of this university you can choose and establish internship in any space company. So if you 90% of internships stay in the company and work there. They get permanent jobs. So this is a golden ticket to get education, to get to employer where we would like to work, and start to work there. Moreover, it's a space mafia, which means that if you would like to have any cooperation and project in space, every cooperation and project are done through connection, because it's small industry, and being part of ICU, you're becoming part of like a large space family. And if you would like to have some project to be worked like that very quickly, you need some, I don't know, like scientists, particular scientists, you need like a space diplomat, you need advice about law, be part of this community, and you will get those advices and help. So next topic is about...
Do you know which program our former finance minister went through? 'Cause she graduated.
Our former finance minister, Dana Reznica Ozoliņa, who is currently in Europarlament, she studied at master program. Yeah, she studied master program. So, yeah, here you are. Now it's. Is there any question about Space University? It's located in Strasbourg. It's Strasbourg. But SSP program has a specialty. It's a 9-week program, and each year it's in a different state. So, for instance, next year, this summer, China. It's going to be in China. So each year it's in a different state. I'm personally really hoping to bring ICU SSP here in Latvia, but it's like 4 years, because it's huge competition, and also it's already pre-planned already. So hopefully ICU will come here one summer. So it will be a great opportunity for Latvians. Is there any? Yeah. Well, for master you need a bachelor. For SSP, yeah, the youngest is a bachelor, I would say. For SSP is more. It's usually the average age was 30 years old, the average age, but they have a policy to have different age groups. So the youngest were, I think, 21, 22, and the oldest were 55. For SSP, it's for those who had a profession or about to have a profession and want to specialize to space industry. Master is generally younger. It's for who just finished bachelor or who have one master and want to have an additional master. And the question was the background. For any background. So as I said, law and policy, business background, managers you want to. By the way, who want to be? Who has a background of project management? Is there anyone project managers here, or want to be a project manager?
Or what if you're learning it as you're going? You know?
So
I'm learning as I'm going, but I didn't professionally study and get a degree in, you know, an MBA or anything like that.
mhm. Sorry, I didn't get your question. It's about project
Well, I
management.
have a question.
Ah.
I wanted to know who wants to be a manager.
Ah,
or
project
you already
manager.
are, just because that's what you found yourself doing.
Yeah, fair enough. Yeah, it's just like there is a job opportunity of space project management here in Latvia at the moment. So if you're interested, just to reach out, just to recall, yeah, just reach out. I will give this link. It's RDL Alpha. They have opportunity currently half-time project management in space sector. As I said, for ISU, yeah, you could be manager, you could be artist, you could be a teacher as well. They accept everyone and re-specialize them to use their profession to work in space industry. So it could be biology, it could be business, it could be, as you saw also previous slide of Space Generation Advisory Council, it's a wide range of topics. Is there any more questions? Okay, and now let's come to Evantech and the business side of space. Let's welcome Pavel Razmaev.
Yeah. I'm here.
Yeah, Pavel Razmaev, please give him a round of applause. I will help him with presentation.
Отдельный слайд тоже там будет, да? Который я тебе потом кидал.
Да, тоже.
Okay. Yeah, okay. Hello, everybody. My name is Pavel Razmaev. I'm representing Evantech, and I'm here to tell you about my own experience about Latvian company working in the space direction, how tough it is, and how actually like fun, how much fun it also is. Basically, who we are, we were established here in Riga as a spin-off from Institute of Electronic Computer Science, if there are any. As I understand, they're mostly from RTU. Yeah, because there is a technology which was matured for a decade, and later on scientists decided to commercialize it, and they went to a commercialized reactor. That's where the company ignited, basically. And the main achievement is that currently we are a technology leader in terrestrial domain in satellite laser ranging, and in 2016 we started our space direction together with ESA. What is our technology is a very precise event process, like timing equipment, precision with a picosecond precision. Basically, we can say when the event happened with a precision of millimeter of a light speed, which is really precise, but it's a very niche application which is required on the ground basically by science mostly, but in space there are a lot of different applications. On the ground, if we talking about the satellite laser ranging, we're working with all around the world. We have to travel to like China, to USA, where like our equipment is well known in a it's widely known by a very narrow like a niche, and as you see, we have more than half of the market, which means that a Latvian company based in Latvia is a technology leader in a specific application. But if we're talking about space, the space becomes really a busy place. Can you imagine a space in 1920 and 2019? There are a lot of new satellites in the space, which have the same picture. 10 years ago, there are really not a lot of satellites in the space. Now there are more and more new satellites. In 10 years from now, we will have at least 5 times more satellites, but if Elon Musk is right, we'll have 100 times more satellites in the space in the next 10 years. And we can see the growth thanks to commercial space. The amount of satellites which are launched by private companies is really large. And there are SpaceX, yes, there are a lot of different companies which are launching hundreds of thousands of satellites with a total value of more than $300 billion, and it's a huge opportunity for space. But if we're talking about the future, let's imagine that every company will have to will have to work under specific regulations. There will be traffic regulations for sure, because there are already different traffic problems. Recently, I heard about one of the from ESA members who was telling that there was one of the SpaceX satellites going really very close to the Aeolus mission, and it was imagine Aeolus mission worth like 100 millions. Will be hit by one of the satellites which cost like 500,000, and then will be yes, ESA will not be happy about it. But we are here to develop a special system which will help for traffic in space, for different kind of missions, for space altimetry, for accurate measurement, for time synchronization, for depth tracking, for navigation. Our system is a kind of subsystem for almost everything when you're working with the light. When you need to measure light, when you need to measure a distance with the light, our system is there. And basically we can supply it for everybody. But why we did it in the space, why we are actually successful, because we develop a Ferrari from the components of a tractor. We already take existing components and we develop something really unique, and thanks to ESA about it. Our path looks like that. In 2016, when Latvia became an PEX member in ESA, we were the first company who submitted proposal to a full space transfer technology. So we took our terrestrial hardware and we transferred to the space. And actually before that, our scientists knew nothing about the space. So we started by our own along this path. And with this, I want to tell you that it's not a problem if you know nothing about the space. It's not something impossible. If you really like it, you can make it. And in 2017, when we had a special event organized by ESA, when they came and just started expanding looking how good we are in progressing of our projects, they recognized that what we are doing is really unique, and they suggested our hardware to be used in one of their mission called Luna 27. It's a ESA Roscosmos mission, and they suggested us to MDA UK to use our equipment for their LiDAR system. And that was how our device was already taken to the mission. And at this point, actually, there was 2 red flags. ESA never takes hardware from PEX countries because they're not a member state, and they did it. And they never take a hardware which is not still developed, and they did it because our project was not finished. So it was really something really unique, because they did the 2 exceptions for us, and thanks to them, they believed in us. And in 2018, actually, the company which took our hardware for the ESA mission, they realized that they need it as well for their commercial mission. So basically, they already had a commercial experience with them as well. And later on, we submitted our next proposals to European Space Agency to develop even further our hardware. Also, they suggested us to another mission called Hera mission to develop altimetry system. And currently, we are developing a small chip to fit our timing unit to the also CubeSats and all our other small missions.
So Hera was just funded.
Huh?
Was the news from ESA yesterday?
No, it's not. Sorry?
Is this a different Hera? The same Hera?
No. The one which with the
The
there
ministerial meeting yesterday agreed to fund Hera.
to fund.
Yeah.
Yeah. To next, because right now there are there are main contractors, there are subcontractors. For example, FSS, with whom we are working, they're developing altimeter model. They already have funding for EM engineering model, and right now they're getting it to the next level, to the CDR phase to critical design review, and later to the QM and all like next steps. Right now, we already handed in our EM model to test it, and actually in December, we are meeting with them in Portugal. Like there are updates that are going on, yes, and they're like step by step. They're not like funding all the mission. They're funding it step by step, and in different like countries there are like specific problems to get this funding. But overall, yes, it's going, I think, really well right now. And who we are Evantech. We have like 8 people in the team. We have a cumulative experience of more than 100 years. Also, Kirill is one of our members in our team who like making it possible with his experience to get faster to the space. Also, we have an ESA head, like ex-head of optics department in our board, who is helping us to get it also faster with his really huge experience. And yeah, it's the end. Thank you very much for your to listening to me, and I hope that you will really like the space, and you will make it your dreams come true if you really want to work. If you have any questions, I will be glad to answer them, and it's not something impossible. If you really dream about it, you'll be able to be an astronaut one day maybe. Or be a scientist working in ESA, and yes, thank you very much. Also, I have one slide. If you're really interested to become like a scientist working in space or an entrepreneur who would like to get like a deep tech, there are like events organized every year. They're called the Deep Tech Atelier, and that's the basically main deep tech events in Latvia during the whole year. Next year it will be already the 3rd event, which will be on 3rd and 4th of April, and there will be like if you want to become an entrepreneur or a scientist, you have an idea, there will be ignition event on the 3rd and 2nd and 3rd of April. Kirill will show you right now. Ты в конец ставил, да?
Кидай нам.
Не, я тебе в WhatsApp скинул. В WhatsApp скинул.
WhatsApp нет.
Не картинку, нет? А можешь загрузить ее?
Давай пока покажу.
Okay. Yes, that's the old one picture I sent to Kirill yesterday, the newer one. But yeah, basically we had this, there will be another one on the 2nd and the 3rd. I just changed it, but there will be different place. It will be in the Hans appearance. If you know, this is a fancy new place. That's where will be happen. Yes, that's the place where if you like deep tech, you can become an entrepreneur or work in this field. And there will be a specific program devoted to educating you how to become like a scientist or how to become an entrepreneur in this field. And there are like will be a huge opportunity for you to make it possible. If Kirill, скачать можешь.
Okay.
Yes, that's basically the new picture. That's a Deep Tech Atelier, which will happen next year in April. Feel free to ask about this event me as well, and you're highly welcome, warmly welcome there. Yes, thank you very much. Any questions? No? Just write down the dates. It's really a must attend event, and hope to see you there.
Next speaker is Karlis Kalniņš. Yeah. He has some issues with the entrance, apparently. Next speaker is Karlis Kalniņš. As you already heard, he is from RTU, Riga Technical University. He is a leading research scientist at Material Science Department, and he has more than 15 years of experience in material science, and he is going to present the topic about space and material science. So while we're waiting for him, how are you doing so far? Yeah, a lot of smiles.
I'm reminded of a story. Can I tell a story that's related to EventTech, actually?
Yeah, sure.
So not only are 50% of the world's precision timers at these satellite tracking stations by EventTech, but there's a clear lineage of satellite tracking that goes from the Soviet era in tracking back to Riga, because in the Soviet era there was a duty you had to perform if you were a student. You had to either work on a collective farm or sign up for other. And other was an unknown thing, and you didn't know what you got, but if you didn't like collective farms, you could do that. So Modest Abele, who was an optics genius at the university, signed up for other. And what it turned out to be was tracking satellites that the Soviet Union was developing, Sputnik 1, essentially. So he became the first satellite tracker, and his companions at the university, and is such a genius that he ended up developing many, many different satellite laser tracking stations all over the world. And then you go on, and he had, I think, this camera that was used for 30 years in 30 countries, because from writing diagrams in the logbook to track satellites, then you can take photographs, and that was his camera. Then they transitioned to laser ranging, and that's what's used today. So there's a really deep history of satellite tracking to Riga and if you want to go see those drawings, you can go to the botanical garden and look in the logbook and see the Sputnik that's drawn in those diagrams there. So it kind of gives you a giddy feeling. Even though it was a weird period of time, and occupation time, there's still this fascination and this space satellite stuff that was deeply in process, only not too far away from here.
Mm-hmm. Yeah, indeed, Latvia has unique companies related to space industry. Actually, we do have, but this is a separate topic. Maybe one day we'll do a separate meeting about space industry in Latvia and the history of space industry. We have pioneers who were at the founding of world level space rocketry here in Latvia. So it's not really well-known fact, but it's true. So Latvia also have connection to space industry even from past. So now, but it's a separate topic, and now I would like to invite Karlis Kalniņš for the stage. No, Karlis Kalniņš for the stage to Kaspars Kalniņš. Sorry,
just Kaspars, that's fine.
Yeah, for his presentation.
Yes,
Mm-hmm. So
I'm absolutely happy here. So I'm thrilled to be here. I'm Kaspars, for those. Reason why I'm here, I think that because you are a young generation. When I was a younger one, I I'm several decades I'm working in a space as a scientist for structures. So the structures were always tricky. Everybody asked like if it's a materials and said, no, it's structures. What's the difference? It's like a cloth and your dress. You're having a cloth you can wrap around with a towel, but the structure is your dress. So I'm making a structure, the dress, not the towel. Anyhow, so in this philosophy, for me, I was the first research fellow going to European Space Agency in 2011. So in 2011, I spent that time in materials and structures, and well, it's materials, sections, assembly, and a lot of things included in a European Space Agency. So having this a year experience in a European Space Agency, this is what I wanted to talk, because my presentation title, which is here, is about material future. I don't know, I wrote it somewhere. I wrote it somewhere and sent it to someone, but anyway, Anyhow, so out of that book, you need to take it out. It's something like your career perspectives in materials, in a space segment, something like that, okay? So something in that direction is my topic of my speech, and I would like to that you are joining in and jumping in. Anyhow, so I started when I was a master's student in my department. We were working on in cooperation with German Aerospace about the structures, how to make them tougher, how to make them lighter, how to apply for aeronautics, including rockets, satellites, airplanes, etc. So growing out of this background, I saw it when it was a first opportunity for Latvia to step in and become gets this opportunity to go for European Space Agency. I signed it up. I get through the competition, and which was not a large competition anyhow. So I went to the European Space Agency to get my job done and actually to try to work it out and to try to understand. Currently, there is an open call for YGTs, which is a young graduate training program. This means everybody who has at least master's degree or master's student level, starting at master's student level, you can sign up to be enrolled in European Space Agency, to have this training for 1 year, 2 years. I don't know if you can extend to 3 years, but I know there's a lot of, those people I know from 2011s, and most of them are there anyhow, but they all started as YGTs. So there's a part of people who are starting as YGTs and staying in European Space Agency or going in a lot of institutions around, as those you know, let's say NASA or SpaceX, or all of those are kind of fellas, you just know them from at times and they're going somewhere. Anyhow, so the idea, I stepped in, I came to the labs and joined the let's say, young graduate groups, which are just an enormous amount of people there, and somebody's penalized to take care of one of those youngsters. So I was a kind of youngster, and I just joined my boss, who for some sake was the same hates as I am, so it was like, oh, you took it by the hate. So like, nah, it was not the case. Anyhow, so we're going around the lab, and I said, he's like, well, this is our top-notch equipment. I said, well, I've been working with this one, I've been working with this one, I've been working with this one. He's like, wait a minute, you're coming out of forest somewhere, and you've been working with all this stuff, and technically, gradually, it proves that I have been really working with all the equipment, and they just gave me work to be done. So everything which went on in a section was kind of giving out, just, yeah, Kasper can do the job. And then I had a lot of good fun. So my boss saying, his quote was, well, how much fun a man could have, So just give him a piece of whatever material you want to test, and then he's happy and he's doing the job. So I really experienced that part. So what it was, there was a lot of tricky parts. So I mean, included, and I fully process all the computer power of some particular equipment. So we did so much tests and so much fun. So we kind of run out of a data space logger, and which is kind of, there's like, wow, we need to have it twice or triple or fifth the size. And then it's like, well, nobody using it. Oh, that's a shame. Anyhow, so people who's making fun, this is what the space is all about. I mean, this is part, if you don't have fun out of what you do, I mean, it's not going to work out. This is not a part of a boring job, even if it contains a lot of things which are absolutely boring. What goes to the materials? Why it's in space is different than everywhere else. I mean, it's a tricky one, because technically you can come up with material which is exposed to plus 300, minus 100 degrees, which is not a typical temperature out there, right? So you never have those problems in it. I mean, it's just like, this is called like a very Finnish problem, so it's like very space problem. You don't have it unreasonably why it should happen, and in space, it's absolutely contrary. It just happened for sake of, what? We never saw it of this one. So what it happens, let's give it a simple example. A section arrived, a piece of tie wrap. Tie wrap is those small plastic stuff we're wrapping around, so €1 costs you like hundreds of those. And it was perfectly made in USA, only manufacturer who does it, and it has a stainless steel, like a tongue, or the securing pin. And all the bag was rusted. So not stainless steel, which doesn't rust, was absolutely rusted. I was like, what? We don't have testing standards for a tie wrap. So like, who in Earth actually needs them in a space? But when you launching up and putting all the stuff in a rack, to be launched up, it's just tie wrapped, just it's not falling down. And only one manufacturer in the world does it because everyone else like, oh, so much pain for one bag of tie wraps, you know? So it came that there's no actually experience what to do with that. There's no testing procedures. There's no what's the reason behind it. So the point was they made it in a rush. So they put in a bag, so all the fluoride was in it, was just coming out of it, and all the stainless steel rusted. I was like, oh, gee, what unlucky, right? So it's kind of like, okay, now you need to do this and this and this and this. So this European Space Agency is something assuring that it makes sense to send it out, and if it's quality, all the things are that it's not going to happen something wrong with it. So it came to the point how to sort it out. What could be, and this is kind of an example which is like a totally, man, how it happens. We had a similar experience with our NASA colleagues in one of our projects. They ordered a full 4-meter diameter, a cylinder for testing, and for some reason it was being delivered in the evening, so nobody actually paid attention because everybody rushed out to home, and it was just not secured on the ground, so it just left there. And during the night there was a nice breeze of fresh air, so it just took it up, raise it up, fly over the fence, and throw it down. So the wind did the job, and it was unlucky situation. And it's some similar with mishaps. I had a project where I need to analyze mishaps. And one of the mishaps which happened was a satellite which fell down from a fully assembled satellite, fall down from the table. And what it happens, it said like, well, as we all have the spare parts, it wasn't so expensive to rebuild it. And mishaps happens, and in a space, you just need to be very open-minded about things, how you analyze the risk and how you can implement it. So to me, my thoughts for you, go there, go for a YGT program, check it out, sign it up. This is one of a lifetime opportunities. Go for it, enjoy it, and then it's the best way how to get yourself introduced in a space and materials or structures or any type of technologies behind it, because YGTs are open for any type of domains and technologies. I'm good with 15 minutes, or I'm too fast? I'm in, I'm out.
Thank you very much. This certain question about materials and space, you can shoot it now. It's your opportunity.
Your background basically?
I'm a structural engineer. I started as a building engineer. I'm a building engineer in my heart. So all the engineers who does the structures, doesn't matter, aeronautics, shipbuilding, whatever, they mainly are structural engineers. The structural engineer, the difference we had between mechanical or aerospace engineer and structural engineer, or assumption, nothing moves. Everything stays still. And mechanical engineers and aerospace engineers, everything moves, and sometimes very slow, very, very slow. As a homes, they're very, very slowly moving somewhere. And for us, everything stays still. So this philosophy is things like, yeah, I'm building a structure, it stays still. I'm a rocket, stays still, and sometimes very, very, something different ratio for safety, okay? That's fine. Yeah?
Are you a fan of 3D printing?
I'm running a project for 3D printing, for additive manufacturing, and I have some, my colleague in ESTEC, he was in a future manufacturing technology, so the 3D printing is there. The point is what to do with that and how to make it profitable on Earth. It's a tricky one. If you're going to do printing on a Mars or Moon or whatever, it makes a lot of sense because you just need much less equipment what you can bring it up. So there's opportunities for it one, as long we are staying here. Well, definitely there's a part which definitely makes sense to print it. But it's not as mainstream as something promising as, I don't know, 5G here. I should say 5G, yes, that's the future. Indeed, there is. The same as additive manufacturing. There's a lot of possibilities what it enables. It doesn't mean that it's really to full extent what we are promising now.
Do you think that Latvia is ripe for a 3D industry, 3D metal printing industry?
Why metal printing?
Because with 3D metal, you can print whole sides of aircraft. You know, with one piece, maybe a little more efficiently than other metal processes. And I've been supporting a colleague who has technology that we were running it through Luxembourg for 2 years, and we did not get the initial money for the prototype that we were expecting. So now he's developing it partly in Canada, partly in Ireland. And when we finish establishing the prototype and that everything works and we get the green light, then it'll go into production phase, and that's when he's interested in licensing it to anyone who wants to license it. And I'm here with my Baltic banner. Yes, we can build an industry of 3D metal printing in the Baltic region. So I don't know. I'm just still listening and going to 3D conferences.
Very
I'm
simple
just
one.
here.
I mean, as I said, I'm running a 3D printing project, which is commercialization. And in commercialization, I'm quite strict with the numbers. And what you said, it makes sense for small pieces currently. Maybe if you're replacing titanium with extremely expensive 3D printing, whatever, and that's not going to make a price crusher. So it's still CNC can do the job much more cheaper, much more affordable. So if you're coming for a very narrow niche, I mean, I don't know, if you're going to print a piece of my heart and I need to insert it, I'm definitely going to share my money for it. But if you're going for mainstream, it's very tricky. So you need this niche is such a niche, and it's a very small one. So investing in equipment and infrastructure, it's a tricky part, the decision. So I would not go for.
The neat thing about this is that it can supposedly work in microgravity. And so this is our 10-year dream, is that we recycle the steel parts from dead satellites in graveyard orbit,
Yeah.
and that there's lots of ways to test it in microgravity, but there's so many opportunities in space with this kind of technology.
Make it affordable.
Yeah.
To me, a slogan for my project is affordable.
Yeah.
Affordable.
Yeah.
That's really a key issue. So currently it's not affordable to the point that it could go in mainstream. It doesn't have the properties, all the rest of properties can try to match it.
Structure buckling.
Yeah.
Issue.
Mhm.
Is it different? I mean, the calculation and the problematic when you talk about space?
No, it doesn't matter. If it buckles your claw like currently, when it's wrinkles, it's buckling, but nobody calculates it. Why should it be? In a space, it's just different safety factors, what you are assuming. You take, when you're coming to civil engineering, buckling calculations and space, it's one part, it's just everything like assumes there will be strangely mishappens. In a space, you take everything. Your manufacturing procedure, your handling procedure, your procedure, which makes imperfections, this imperfection, and you account all of that. And if you account all of this, your margin of uncertainty really narrows down. So in civil engineering, we have so much margin of uncertainty. In space, we have very, very, very little. Well, it's not a minimum. It's a minimum, but not like a zero. Yeah. Good to go? Yeah.
Thank you very much, Kaspar.
Cheers.
Kaspar Skalnic, thank you very much. Oh, okay, let's recap what we have.
Some beautiful pictures, by the way, in the background.
It's
Those are gorgeous.
Cheers. Thank you very much. Where is my? Yeah. So as we said, the first official part is about to end. A speaker session is about to end. We will have 1 hour break. We'll have 1 hour break for lunch and networking, and the next part is for those who would like to take part in Space Generation Advisory Council activity next year. So we are going to make a plan, make a brainstorming, what possible activities, like, I don't know, a space party or like different conferences. Also, you may stay if you would like to suggest what you would like to see next year as a plans, like monthly events, like, I don't know, film space nights or
How are these funded? Because events and, this costs money.
Well, it is possible to find certain sponsors. This would be also part of the brainstorming activities. And I also would share information I recently got that we will get funding for several projects, research projects for students, which we will make known and available through our network. So please. So what's important is please write down this information. Let me just wait a second. So I'll pass this one. So please write down information about. Nope. Yeah. So Space Latvia. Here will be information at Facebook. It's a page. Information about all projects, all events, all different activities. Based in Latvia, and also about Latvian startups connected to space. And another important date, 17th December, it's a strategic meeting of Space Generation Advisory Council activities. So we will come together and discuss and make like strategic plans for next year in Latvia. How to develop space generation advisory, space generation here in Latvia, how to bring Latvia in space.
So where are the people? Are they in Riga mostly, or scattered all?
Well, Space Generation Advisory Council is Austria-based company, so they're all based.
No, but the strategic meeting is.
It's for those who from those who decide to join. So it's currently there is just one national point of contact here in Latvia. It's still there are two possibilities, two vacancies, and yeah, and we are looking for up to six people team of space enthusiasts who would like to make different activities in next year. So all about this in details will be in the next next session. So now it is 12:20. Let's meet up for the second part, 1:30. So thank you very much for your time. Thank you very much for your attention. I was really glad to see everyone. Hopefully you will reach your space dream. And good luck. If any questions related to space, feel free to reach out. I will make myself available for such questions. Okay, thank you very much and have a good day.